mechanism or series of links together. So control systems need to be able to sense and change the parameters and then adjust and refine their movements accordingly. This is a basic loop of a control system. So think of it as driving a car. You've got your R as your input, so you see a corner, you turn your wheel, then that's your controller, so you're turning the wheel. The system then changes accordingly. And if you're turning too sharp, you take steering off, which is why it comes down to Y value, comes back and feeds back into the loop. If you're steering too little, you put more on, it comes back and does the same. So you're constantly tweaking to keep in order with the control of your vehicle. Yes, closed loop system, so just continually moves the whole time you're within the process of steering or whatever you're controlling. This is the negative feedback, which is sort of built on your control, which is the same idea of if you steer, it's how you manipulate that data, how you read it, interpret it, and then readjust your steering. Yeah, I think that's, well, that's quite crudely, that's how negative feedback will work in a system.
Very good. Did mention this very similar again. We at the start we're looking at how taking information, so say with the steering wheel you turn it all the way to the left, is then looking at how much you would actually have to interpret taking it back. And it's also looking at in the real world when you get into a car for the first time, so you have no idea how much you need to turn the steering wheel. So we're looking at using that, putting it into a graph and actually seeing how long it would take, say, if you were in a car to constantly steering left and right to actually get it to be really smooth. And that is basically also what we're trying to get into the robots.
Yeah, building that point, you'll find anyone that's been in the car very often or just got in it, the steering is very much big turns left, right, as opposed to smooth corrections as to gently turning it. Which is why if you look at a very basic control graph, it oscillates a lot, fluctuates, because you're trying to get the steering right. It goes big turn, it slowly levels out as you're getting used to it or control it properly. And that was just another feedback loop, which is the same idea, same principle, with different values and different sort of titles for the different sections. And this goes on the gain of a system. The gain of a system is when you put back into the loop how much that influences your input. So say you turn 30 degrees, you might take 5% of the value of the turn into your feedback network, and the gain is how much you take your actual turning and recycle it to adjust. Yeah, this was a project brief, which is to design a robot that navigates a predefined layout, which you probably see when you came in. This is using parameter sensors such as seeing what's in front of obstacles, start-stop, and lasers to pick up black and white colours. Yeah, and then we're using the software side of it to actually got the boxes on top, which we'll show you later on the demonstration, the LCD displays, take them off and you program them to work for this circuit or any circuit with a black and white line.